formulation of Einstein's theory.
There, right there.
Time to get up, ladies. Go, go.
I believe teleportation is possible, but I've got one major problem to solve: how to turn a staggering amount of pure data into a living, breathing person. With just a stockpile of atoms and a set of digital instructions, my teleporter machine should be able to fabricate any object. Something like the replicator from Star Trek would do the trick. A machine as advanced as that is maybe only a century or so away. Futurologist Mike Tretter is already thinking about how it might work.
Whether you call it a nanofactory, a replicator, a fabricator, could have different names. The idea is they'll be able to assemble things atom by atom with molecular precision. It seems almost certain they'll be able to create complete living organisms at some point in the future, although it's very challenging.
We could get an idea of how this might work by looking at one of today's state-of-the-art 3D printers. First, the object to be assembled is scanned, creating a 3D digital image. The system then breaks this complex data into simple 2D slices, which it sends to the replicator-style assembly machine. The device fabricates an almost exact likeness of the object layer by layer with almost surgical precision. Now, this machine obviously has not created an exact copy of me. This is just a three-dimensional reproduction of my face. Think of it as a 3D photograph. But in the future, using similar principles, it should be possible to create a living, breathing copy. Using cutting-edge science and a little bit of science fiction, I think I've got the design for a truly awesome teleporter. I wonder what the sci-fi fans will think of it. Today, I'm going to present to you the first workable design for a transporter. And we're going to answer the question, when are we going to be able to zap our molecules into outer space? The world's first teleportation passenger steps into the scanner. It's made of non-magnetic materials to resist the powerful magnets. Now, pulsating radio waves start the job of converting atoms into pure data. 35,000 billion gigabytes of it. I need to transport that mountain of data to its destination. You have about 10 to the 25 atoms inside your body. Now, an ordinary laser beam cannot carry that amount of information. Instead, I pack the data onto a beam of X-rays many feet thick and fire it straight as an arrow up to a geostationary satellite above the Earth. It would be possible for someone to intercept this beam and make an unauthorized copy of the person. So I've added an encryption device to keep the data secure. Next, the beam is sent hurtling at a fabricator station on the other side of the planet. The data arrives, and an advanced quantum computer starts the billions of computations necessary to open up the instructions. It has to be received by a computer that can handle this vast amount of information. Now the data is unraveled, a molecular assembly machine begins to piece everything together. The scanner opens, and an absolutely perfect copy of our teleportation pioneer steps out, safe and sound. But this leaves us with one remaining problem that could inspire a science fiction movie all of its own. The body at the departure point is still there. He was only scanned, he wasn't dissolved. Things could get complicated if teleportation really takes off. Luckily, we've got a while to iron out that little wrinkle. So there you have it. In the next few hundred years, we'll be zapping our molecules through space.
It's really interesting. I really do see it happening.
We're going to see it sooner than we think.
Volunteer? If I can interview my double before they kill me. Yeah.
What?